to Coulomb Academy. Dear friends, in this series of mechanical vibration numericals, I am taking the numericals, different numerical on the free damp, viscous damping. Today's example, this figure shows, this is the figure, you can visualize this figure. This is a container in which this shaft along with the disc is immersed. The disc is we are rotating this disc, so it will generate the torsional vibration. So due to this rotation of this disc, what will happen? It will create a torsional vibration. The rotation is like this, circular rotation will be there, and it will rotate in this direction or in this direction. So what is the given in this numerical? I will read it. The torsional pendulum. This is nothing but the torsional pendulum with a disc. This is the disc of moment of inertia. Moment of inertia I. Here I is equal to 0.06 kg meter square. Okay. It's a given data. The pendulum is immersed in a viscous liquid. This is the viscous liquid. This pendulum is immersed. Okay. What will happen? During the vibration of this pendulum, the successive amplitude decay with 66.6%. Okay. This much decay will be there. Means what? When this pendulum will rotate, so decay will be like this, because this is the damp frequency. It goes on decreasing. Goes on decreasing like this. Okay. Or like this, you can visualize. So this shaft is having some modulus of elasticity. That value of the stiffness we have to find out. That may be here represented in this diagram Q, or we can say KT. That we have to find out. Okay. So this stiffness also, it's not given to you, but this diameter is given to you. Diameter of the shaft D, small d is 10 centimeter, and this length is given 40 centimeter. In centimeter is given, and I means mass moment of inertia for this disc 0.06 kg meter square. It is given to you, and directional, that is the successive amplitude decay, is given to you. So what we have to find out? We have to find out the logarithmic decrement. Logarithmic decrement means what? Del. This del we have to find out value of the del. Logarithmic decrement is how much? After that, the damping torque per unit velocity, that means the C, damping coefficient. We can say the damping coefficient we have to find out, because this is the torsional pendulum. It's create a torsional vibration. So damping torque per unit velocity, that we have to find out. So next is the what? We have to find out this C. This term is time period for the vibration, and this is a torsional damp. So TD we have to find out here in this case. Lastly, frequency when the disc is removed from the liquid without any immerse. What will the frequency? So it's like a natural frequency, it will rotate. So that Fn we have to find out. Okay, without immersing inside the liquid. With the immersion in the liquid, we have to find out first, and without immersing, that we have to find out. So friend, what is the given and written here? For the disc, data is given mass moment of inertia I is equal to this 0.06 kg meter square. For shaft, what is the data is given? For the shaft, and this is for disc, the diameter is given 0.1 meter. Is 10 centimeter. Length of the shaft L is given 40 centimeter, means 0.4 meter, and this modulus of elasticity the 4.4 into 10⁻⁻10. So what is the next step? We have to find out the logarithmic decrement. Step 1 is we have to find out the logarithmic decrement. That is then how we can find out? By using this formula. This 1 by n log to the base e x0 by x1 or xn. what is the given data? The 66.6% successive amplitude decay is given to you. That I will write here. What is the given data? That x0 by this x1 is 66% decrease, means x0 upon, I will write here 66% means 0.666 into this x1. The x0, sorry, here is the x0, means this much 66% it is reduced than the first one. Here you can observe in this curve, here is the, suppose x0, the reduction in this variation in this one become less, means the first I will draw here diagram. ये पहला जो है wave, second wave like this. This first one is the x0 and this one is the, here this one is the x1. So ये reduce होता है कितने, how much percent? 66%. So that is, here relation is given. So from this relation you have to find out the value of del. So we'll get the value of del is equal to, is how much? 1 by 1, means n is, in this case n is for one cycle successive. So log to the base e upon x0 upon 66%, means 0.66 into x0, that way to find out. Means what will happen here? Log to the base e 1 upon 0.666. Okay, like this value we have to find out. So I will write here formula, and the value of logarithmic decrement. What is this? This is your logarithmic decrement. Okay, this is the value. We'll get it here, 0.4. How much? 0.4054. This is the unit list. Okay. Now what we have to find out? The second step, step 2. In step 2, as we know the value of this del, okay, 0.4054, we can find out by using this Zeta. So what we have to find out in step 2? Damping torque. That means C we have to find out. Value of C we have to find out. That's calculating the C. What is the formula for this C? C we can calculate from by using our regular formula of this. C is equal to, or the Zeta. By using the Zeta also we can find out this. But for this purpose Zeta we have to find out. How we can find out the value of Zeta? By using this value of the del. What is the formula for del? 2 pi Zeta by under root of 1 minus Zeta square. Correct? This Zeta value, this we have the value find out by using this value of del. Putting this value of del in this equation, we'll get value of this Zeta from this equation. I will write here. Zeta is equal to 0.064. Once we find out the Zeta, value of Zeta, we can find out this C. C, I will write the formula for C. C is equal to 2 into I Zeta into under root of the K by I. K means KT. KT by I. We will write this formula again. 2 into I means moment of inertia into Zeta under root of KT by I. Okay. Or we can write here like this also, 2 into Zeta inside the bracket I into K, or Km, 2 Zeta into Km for the linear vibration. So putting these values of I we know. Here value of I is given to you, this one 0.06, and we know the value of k, we don't know. So from this also we can find out the value of k, but this value of k, to find the value of k, I will write here, okay, here in the side of this one. To find out the value of k, we can find out k is equal to, means kt, not k, it's kt for the torsional vibration torque. Kt is equal to Gj by L. So this is the formula for the kt. From this formula we can find out this what? Kt. What is the value of G? G is given to you. You know the value 4.4 here. G is given to you 4.2 into is 4.4 into 10 raised to 10. Okay. What is the value of J? J, nothing but this value we can find out by using the formula pi by 32 into d raised to 4. D raised to, so total in the denominator, what is the value? Denominator L. L is given to you, that is the 0.4. Its total length is given to you 40, L is 0.4. So this is the value. D is also given to you here 0.1. Here D is also given to you 0.1 value. So this KT becomes, we can find out by using this one. Just calculating these values, and this value of D here, value of D is how much? Here this value of D is 0.1. Okay. So putting these values, you get the value of KT is 1.08 into 10 raised to 6 Newton meter per radian. This is the value for the KT. Put in this equation, value of this KT, we will get directly here. Value of C becomes, how much the value of C then? And value of C becomes 2 into Zeta. Zeta is how much? 0.064 inside the bracket, 4.4 into I. Value of I is how much? 4.4 into 10 raised to 10 into value of this K. K means KT. Here K means KT. KT is just we calculated 1.08 10 raised to 6. This is square root. थोड़ा समझ लो, understand करो. Okay. This C becomes 2 into, I will write again, once again, 0.064, 4.4 10 raised to 10 into 1.08 10 raised to 6. So what is the value then? I will write here value of C. That will be the 32.8 Newton meter per radian. This is the value of C. Means what? The torque, damping torque. Here damping torque per unit velocity C. That is the damping coefficient we have calculated. Now we have to find out the next value. That is the your value of this. We can say what we have to calculate. We have to calculate the TD, means time. Time we have to find out. This time. How to find out the periodic time? The third step. Here we have to find out the periodic time, means T into D. So how we can find out TD? The TD we can find out by using this formula. This TD is equal to 2 pi by omega D. But how to find out this omega D? Omega D is equal to omega n under root of 1 minus zeta square. But how to find out this omega n? This omega n we can find out by using this formula. This omega n we can find out by using the formula, this kt by I. and this is the torsional vibration. So first we have to find out the value of omega n. Omega n we can find out by using this formula. What is the formula? This kt by I under root square root. So just putting this value 1.08 into 10 raised to 6 denominator. What is the value given to you? The I is 0.06. Value of I is given 0.06 here. So putting this value, we will calculate the omega n. The value of omega n from this one is 4240 radian per second. From this omega n we can find out this omega d. Okay, by using this formula, this one. So putting this value, we can find out the omega n, or directly put this value here in this one, and we get the values of the omega n into the TD. 2 pi by omega n is 4240. Here this formula 1 minus zeta is how much? Zeta we have just calculated here, value zeta is inside the bracket 0.64 is square. This is the for calculation. We have to do the calculation here and we'll get the time. What we'll get here? We'll get the value time, periodic time 0.0149 in second. This is the answer for the periodic time. This we have calculated. We ask in the second step, third step, we have calculated periodic time. Now what we have to do? Step 4, to calculate the frequency. What we have to find out? The frequency when removed, this liquid is removed. Inside there is no liquid. Consider inside there no liquid. In that case, the frequency when liquid removed. So how to find out this frequency? Omega n is equal to 2 pi Fn. This is the formula for the finding the natural frequency. So where to find out the Fn? So Fn, how we can find out? We can find out by using this formula, omega n by 2 pi. But we know this omega n is, this value just we calculated here, 4240 upon 2 pi. So what is the Fn then? Fn become your 675 Hertz. When this is the frequency of oscillation for the torsional vibration. This is the frequency of oscillation for the torsional vibration. Okay. When this liquid is removed, means this viscous fluid is removed and this is rotated. This disc is rotated without when liquid is removed. When liquid is removed. So this is the fourth point we have just calculated. The frequency when the disc is removed from the liquid, means without liquid this disc is rotated, vibrated. So friend, this is the numerical covered for this. Please, if you not subscribe my channel, please subscribe my channel Coulomb Academy. Thank you very much. What are the outcomes of this video of mathematical modeling for this all the vibrating system? Write down 3 outcomes. And friend, here you always learn by self-assessment only, and you have to subscribe my channel Coulomb Academy. If you are not subscribed, please subscribe it. Thank you very much.